Hey everybody, in this video we're going to practice finding antiderivatives with the power rule. So we've already done practicing finding derivatives. Antiderivatives is basically just doing it backwards. And so if you know how to do it one way, doing it the other way isn't that much more difficult. Some calculus teachers want you to wait for a long time to do antiderivatives. I disagree. I think if you know the derivative rule, finding the derivatives is pretty straightforward. If you want to follow along, the links to the companion worksheet are in the description below. So let's get started. So for number 1, we're given that f prime of x equals negative 8x. So what we want to find is we want to find what is f of x. Well, again, all of these follow power rule. So this is negative 8x, but we could think of it as x to the first. Well, with power rule, the exponent always goes down by 1. So the question is, well, that means it had to be 2, but what about the coefficient in front? What would that have to be? Well, that would have to be negative 4. Why? Because if you were to take this derivative, the 2 would come down and multiply and then add and then become negative 8. Now, the thing to always be aware is that anytime you're involving an antiderivative, that is, going from the derivative to the original function, you open yourself up to the possibility that there was some number that was being added or subtracted. Now, the derivative of any number is 0, so it won't show up there. And so what will often happen that you'll see is that anytime you find the original function, having taken an antiderivative, you'll see a plus c written. The plus c is there because it's a reminder that, well, there could be some unknown constant that was being added to it. And so we always put a plus c when we find these types of antiderivatives. So for the next one, for number 2, here we have negative 24x cubed plus 8x. So f of x is going to be, well, if it's x cubed here, that means it had to be x to the 4th to begin with. So if we brought down the 4, we should get negative 24. So that means it should be negative 6. Now, we already found the derivative of negative 8x. The antiderivative of positive 8x is just positive 4x squared. And again, we add the plus c in case there was some unknown constant that wasn't there. All right. Now with number 3, this one always trips people up a little bit. Here we have 4x to the negative 5. So if I want f of x, we have to remember that with power rule, the exponents go down by 1. So that means if it was negative 5 for the derivative, in the original function, it had to be negative 4. That's what it had to be. And so what was the coefficient? If we brought down the negative 4 and we got 4, what should it be? And that should be negative 1. And again, we add plus c to the end of it. So looking down at number 4, here we have negative 5x to the negative 3rd plus 8x to the negative 4. So f of x, well, if it's x to the negative 3rd in the derivative, that means it has to be x to the negative 2. Now, what is this? If we bring down the negative 2, we get 5. How does that work? Well, if you look back, there's kind of a relationship that you can see. If you take the coefficient that's there and divide by the power in the original function, you get the coefficient that you want. So here, negative 24 over 4 is negative 6. Here we have 4 over negative 4 is negative 1. So here we take negative 5 over negative 2, and that gives us 5 halves. There we go. So now, if I want x to the negative 3rd, then we take the original coefficient 8 and divide by this exponent, negative 3. So we have negative 8 thirds x to the negative 3 plus c, our unknown constant. Let's move on to the next page. Now here, it's written as 15 over x plus 7x to the negative 2. Now, quite simply enough, we can rewrite this as 15x to the negative 1 plus 7x to the negative 2. So what is f of x? Now this one gets a lot of people into trouble because this one actually requires a little more than power rule. This one actually requires some knowledge of some other derivatives, because a lot of people try to just apply power rule universally. And so they'd say, well, if x has a -1 exponent right here, that means the original function, it's just 0. Well, that would make it just a constant. And the derivative of any constant is 0. It's not that. So what is this? Well, remember, x to the -1 is 1 over x. So what this is ln of absolute value of x. And then over here, we have x to the -2, so that means that had to be x to the -1. And so we divide our coefficient by the power that's there, and so we have -7. So for number 6, a lot of people like to think that there's a quick and easy quotient rule for antiderivatives. Fortunately, there isn't. So what we have to do is we have to simplify this algebraically first. So we have x squared over x plus 11 x over x plus 9 over x. And so we can simplify that to x plus 11 plus 9x to the -1st. All right. So what does f of x have to equal? Well, if this is x to the 1st, then that means this has to be x squared. But there's no coefficient out here. So what happens when we bring down the 2? Well, it has to cancel. And so the number that will cancel out 2 is 1/2. Now 11 we can think of as 11x to the 0 power. So that means it has to be 11x to the 1st power. Now here we have x to the -1 again. So this is another example of not power rule, but using natural logarithm. And people ask, why do you have the absolute value? Well, the reason the absolute value is there is because logs normally don't like negatives. That's the normal rule. But if you look at the derivative is okay with negatives. You can raise a negative to a negative power. It'll work. And so if the derivative is okay, then that means the original function has to be okay as well. How do you make that happen? Well, you make ln have absolute value inside. And then all of a sudden, negatives are okay. And then you can plug them in. So that's why you'll often see ln with absolute value on them. It's because you took the antiderivative. So for now, number 7, here we have 6x to the 1/3. Now we're finding the antiderivative. So that means x had to be to the 4/3. And so we would take, to get our coefficient, we would take 6 over 4/3. But that's kind of awkward. So let's rewrite that. Now instead of dividing fractions, which actually mathematically doesn't exist, the only thing we really do is say, well, what is that really? You're really multiplying by the reciprocal. So you're really multiplying 6 by 3/4. And so what we get is we get 9/2 x to the 4/3 plus c. Whoops, I forgot that. I forgot my plus c's. Wow. Should not be doing that. Always remember, always add that plus c. So number 8, here we have radicals, but those are just really x to the 1/2 and 8x to the 1/3. And so we can find the antiderivatives of these no problem. If x is to the 1/2 for f prime, that means it has to be to the 3/2. So I'm going to be taking 4 and dividing by 3/2. We'll deal with that. If x is to the 1/3, then that means it has to be to the 4/3 for f of x. So then we have 8 over 4/3. All right, so a little simplifying here. So we're going to take 4 times 2/3 x to the 3/2 minus 8 times 3/4 x to the 4/3. And so we have 4 times 2/3. Can't simplify that, so we just end up with a fraction 8/3 x to the 3/2 minus, this can simplify to just 6 x to the 4/3. And we add plus c on the end. Okay, so now Now what we're looking at is we want to find what's called the particular function. All the functions before, we were just finding an antiderivative, but we didn't know anything more about the function. Here, one more piece of information is given. So for all the problems after this, there's not going to be any plus c, because we only plug in plus c when we don't know what that number is. Now, for these problems and all of these problems to the end, we will know. So looking at f prime, it's 4x. But f of 0 is 6. So that means for whatever the original function is, if we plug in 0, we should be getting 6. All right. So what is f of x? Well, if f prime is 4x, then that means f of x equals 2x squared plus c. We use this piece of information to find c. Plug in 0 for x and 6 in for f of x. So 2 times 0 squared plus c. So that means 6 is the value for c. So in our case, our particular solution for f of x is 2x squared plus 6. No plus c. Here we have a specific number. For number 10, here we have g prime of x equals 6x squared. So g of x has to equal, well, x has to now be to the third. So 6 divided by 3 is 2 plus c. So now, if we were to substitute 1 in for x, we get negative 1 for g. So 2 times 1 cubed plus c. So negative 1 equals 2 plus c. So we subtract the 2, we get negative 3 for c. So g of x, our particular function, is 2x cubed minus 3. For number 11, here we have h prime, and then h of 1 equals negative 4. So h of t equals, here t is to the third, so in the original function it has to be to the fourth. And I take 8 divided by 4, so my coefficient is 2, plus 5t plus c. So now I substitute 1 in for t and negative 4 in for h. 2 times 1 to the fourth plus 5 times 1 plus c. So we have negative 4 equals 2 plus 5 plus c. So we have negative 4 equals 7 plus c. So when then I subtract the 7, c should equal negative 11. So our particular function here, h of t, is going to equal 2t to the fourth plus 5t minus 11. For number 12, here we have f prime of s. So if we want f of s, here s is to the first power, so it's going to be to the second power. So I take 6 divided by 2, so my coefficient is 3. Here s is to the second power, so now it's going to be to the third power. I take 8 divided by my power, so my coefficient is 8 thirds plus c. Okay, so now 2 goes in for s and 3 goes in for f. So 3 equals 3 times 2 squared minus 8 thirds times 2 cubed plus c. So 3 times 2 squared is 12. 2 cubed is 8 times 8 thirds is 64 over 3 plus c. All right. So if I subtract the 12, I'll have negative 9 equals negative 64 thirds plus c. And let's see, negative 9 is the same as negative 27 over 3. So that way we have common denominators. So when I add the 64 to the other side, I should get 37, positive 37 over 3. That's my value for c. So my particular function here, f of s, equals 3s squared minus 8 thirds s cubed plus 37 over 3. All right. Now on this last page, now we're given the second derivative. So that means we have to find the antiderivative twice. So here we're first given that f double prime of x equals 4. And the thing to notice is that with these two pieces of information, these are particular points because they just give us the values at a specific spot. Whereas here, f double prime is for x. So that means at all values, it follows this pattern. So now we have to ask, well, what is f prime of x? Well, if f double prime is 4, then f prime is 4x plus c. So we substitute 2 in for x and 5 in for f prime times 2 plus c. So that means we have 5 equal to 8 plus c. So when I subtract the 8, we get negative 3 equals c. So that's f prime of x. We get 4x minus 3. But now we have to take the antiderivative a second time. So now we have f of x. So we have 4x, that becomes 2x squared, minus 3 becomes minus 3x, and then we still have the plus c. Now when I plug in 2 into f, I should get 10. So 10 equals 2 times 2 squared minus 3 times 2 plus c. So 10 equals 2 times 2 squared, that should be 8, minus 6 plus c. So 10 equals 2 plus c. So when I subtract the 2, I get 8 equal to c. So f of x equals 2x squared minus 3x plus 8. There is our particular function. So now on to 14. Here we've got f double prime equals x squared. So what does f prime of x have to be? Well, that has to be x cubed. Well, what's the coefficient? Well, it has to cancel out because there is no coefficient. So that means the coefficient has to be 1/3. So it's 1/3 x cubed plus c. So when we plug in 0, we should get 6. So 6 equals 1/3 times 0 cubed plus c. That zeroes out. So that makes it a little easy for us to say, well, that means 6 has to be our value for c. So f prime of x has to equal 1/3 x cubed plus c. Whoops, no, 6. It's a particular solution. We know what that is now. All right, so now we take the antiderivative again. So f of x equals, now it becomes x to the 4th. So we take 1/3 and divide by 4. So that's going to be 1/12 plus 6x plus c. Now to save ourselves some time, hopefully you've noticed that if you plug in 0, 6 is going to be your c value. And that's going to be the same thing here. So I'll just jump to the end. 1/12 x to the 4th plus 6x plus 3. Okay, on to our last one. Here f double prime is x to the negative 3/2. So that means f prime of x has to be x to the negative 1/2 power. So what's going to cancel negative 1/2? Well, that's going to be negative 2 plus c. Now, unfortunately, we're not plugging in 0, so we'll have to plug in this value. So 2 equals negative 2 times 4 to the negative 1/2 plus c. If we raise up something to the 1/2 power, that's the square root. If we raise something to the negative power, it's the reciprocal. So here we're doing both. Here we're taking the square root and the reciprocal of 4. So that's 1/2 plus c. So now, negative 2 times 1/2 is negative 1 plus c. And so if I add the 1, we get 3 equal to c. So our particular function for f prime is going to be negative 2x to the negative 1/2 plus 3. All right, so now we can find f of x. So for f of x, f prime was x to the negative 1/2. So now it's going to be to the positive 1/2 because we add 1. Now the coefficient was negative 2, but now it should be, let's see, it should be negative 4. Yeah, because when we bring down that 1/2, we'll multiply by that, and that should become negative 2. So negative 4 is our coefficient, plus 3x plus c. Now here we can save ourselves some time because, hey, we plug in 0, we get 0. So our constant for here is 0. So our final function is negative 4x to the 1/2 plus 3x. If you liked the video, please give it a thumbs up. For more videos like this, click the subscribe button. If you're a teacher and you like this, consider sharing it with your students. Or if you're a student and you like this, share it with your classmates. If you have suggestions or problems that you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching. And remember, the only way to understand something is to do it.